Hi, this is Ike. So it's that time of week again. We're back on LeetCode. I'm just gonna go over here to the pick one and let's search for an easy problem. Okay, so this one is titled delete node in a linked list, and it says write a function to delete a node in a singly linked list. You will not be given access to the head of the list. Instead, you will be given access to the node to be deleted directly. It is guaranteed that the node to be deleted is not a tail node in the list. I think that'll probably help us out a lot. Uh, I'm automatically thinking we'll need to use this assumption here. Uh, and so I guess it's fairly clear what we need to do, but like say if there's a uh, node that we want to delete with value 5, then we just need to take 5 out and then have 4's next point to 1. So 5 will be gone. And then these are just a few more examples, like 4 to 5, 5 to 1, 1 to 9. We want to remove 1, so then it should just go 4 to 5, and then 5 to 9. And let's take a look at some of these. The number of nodes in the given list is in the range 2 to 1,000, and the values are bounded between -1,000 and 1,000 inclusive. And the value of each node in the list is unique, and the node to be deleted is in the list and not a tail node. Okay, so I think we just need to step through the list. We just need to step through the linked list until we find the node, but then we also have to deal with connecting it. We can't just remove it or else we'll lose our current position. So we need to go through the list, actually find the node to delete, but then look at its next and connect the previous node to this one's to the deletion node's next. So like we'll start at 4, then get to 5. We'll see that 5 is the thing that we want to delete. So then we'll say that okay, 4 should be pointing to what 5 used to point to. And so that'll essentially like remove 5 from the list. All right, so let's go over here to start coding it up. Uh, so we have delete node and self node, and node is just one of these. And yeah, so let's just say uh, we'll use a different variable for iterating through the linked list. So we'll say current equals, actually, wait, hold on, write a function to delete a node in a singly linked list. You will not be given access to the head of the list. Instead, you will be given access to the node to be deleted directly. Wait, hold on. So we have to delete a node in a singly linked list, but will not be given access to the head of the list. Instead, you will be given access to the node to be deleted directly. Okay, so this node is the one that needs to be deleted. Oh, that's pretty interesting. Oh, okay, so I had some wrong assumptions. I was thinking we just had to like we would get the head and then we have to iterate to it and then delete the node. But it looks like we don't get all of this. Like we just get this. We just get this shaded node. And then our task is to delete. Yeah, we just get the shaded node, and then we have to somehow delete it from the linked list, uh, assuming, or delete it from the linked list without using the head. But all hope is not lost because I think we can, if for sure that the node to be deleted is not the tail node, we know for sure it has a next. Uh, so one thing we could do is we could just copy over the value from the next node to this current one that we're given, and then we can remove the next node, and that should have the same effect because then in this case we would start with we'd be given 5, we would look at the next, which is 1, copy that value over. So I'll just write the example down here real quick. So we start with 4 to 5 to 1 to 9. And so then first we copy the value over. So the node to delete will have value 1. And then we can go ahead and remove this next node. So then we just will get the 4, 1, 9. Okay? So yeah, let's try this out. So I'm going to delete that current thing actually. So the first thing we want to do is we'll say node value is going to be equal to node value, or sorry, node. Wait, I'm writing in the I'm writing in the wrong language right now. So node.value should be equal to node.next.value, and so whoops, we'll say possible since node is not a tail node. Like, so we know for sure that's going to be valid. Okay, and so then now we just need to delete node.next. All right, and so we'll say next. Actually, we can't use that. We'll say next node is going to be equal to node.next. And then we can just say node.next is going to be, actually, let's do, so basically the problem essentially becomes like deleting this node. We're trying to delete the node right after the shaded node in all of these different cases. So then I think we just have to say, we know that there's a next node. So we'll say, I'm just going to say next node equals node.next, and we'll delete this and just replace it with next node. Okay, so now we'll work on deleting next node. So we'll say node.next is going to be equal to next node.next. So this essentially says if 5 is the given node, then 1 is the next node, and 9 is next node.next. So what we did was we first copy the next node value to the given node. So 5 becomes a 1. And then we just delete this node by saying that node.next is equal to next node.next. So 5 gets attached to this 9 here. All right. And I think that actually might be sufficient to delete the node, because technically, as long as we make the 5, like skip over this 1 and connect it directly to this 9, then it should be good. So let's see, do we need to return anything? Void. Do not return anything. Modify node in place instead. So yeah, I'm thinking, let's run a few of the example test cases, but I think this should be good. Okay, so yeah, we got the 419 there. So actually, yeah, let's go ahead and submit. All right, cool. So it looks like it worked. All right, so we just solved delete node in a linked list. If you enjoyed this video, please remember to like and subscribe, and also let me know in the comment section down below if you have any ideas for future live coding projects. Thanks.